Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout, hosted by Russ Parsloe. Today, Russ is going to walk through some of Consul's lesser-known features, such as semaphores, watches, remote execution, and blocking queries to help reduce the complexities of building out your services across distributed infrastructure. I also want to note that this Hangout is recorded, and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. The demo will be about 20 minutes, and then we'll allow up to 30 minutes afterward for questions. Please go ahead and feel free to submit your questions throughout the demo through the GoToWebinar portal, and then we will answer them at the end. So with that, let's go ahead and get started. Take it away, Russ.
Awesome. Thank you so much, Amanda. You're really the sort of unsung hero of these webinars. I get to talk, but you do all the hard work, so thank you. So contrary to popular belief, I'm not the in-house DJ for HashiCorp. I'm one of the solutions engineers over here in London. So I'm based in kind of sunny London at the moment. And yeah, today I'm going to talk a little bit about Consul, about the features that people maybe haven't really heard of. I know there's a lot of people who are very familiar with Consul. There's a lot of companies and organizations that are really using it, but there are some features that are in there that maybe you didn't even realize existed. So the agenda is going to be pretty easy, pretty quick, pretty lighthearted. Going to give a very quick introduction to HashiCorp Consul. There may be some people who have heard of it, but don't actually really know what it does, let alone those kind of features that no one has really heard of. So I'm also going to cover very, very briefly what it is well known for, some of those features. I'm going to spend most of the time talking about what else it is that that Consul can do. And then I'm going to go through a kind of a step-by-step demo. It's going to be quite a simple demo because some of these features are going to be new to people. So you'll actually be able to kind of follow along. And I've even included some of the scripts I've used. And as Amanda said, we're going to have a Q&A at the end. So any questions that you may have, we've got time for them at the end. So a real brief introduction to what Consul is. It's actually probably one of our oldest tools. It was introduced in 2014. It's had an awful lot of development, obviously by ourselves, by our community as well. We've got a huge community around it. It's one of our most stable and well used products. Very popular product. It's got 14,000 stars on GitHub. I think when I looked at this not too long ago, it was like 12,000 stars. So it's increasing in popularity. It's getting around about 1 million downloads per month. That's probably a little bit conservative. I was lucky enough to be at AWS reInvent recently, where they gave us permission to share the fact that Consul is the most widely used tool of its type across all of AWS. So it's an exceptionally popular product. And just to give you the idea, this is not just something that people are running on a really sort of small scale, or it's sort of fairly boutique or fairly niche. We've actually got some customers who have this sort of across sort of 50,000 different systems. So it's used at really, really high scale as well. This is, I'm not going to go through every single detail of this, but just to kind of explain that the way Consul essentially works, the way that we actually architect it is we have a series of systems that operate as servers. It's an odd number of systems. So in this diagram, I've got 3 servers, typically either 3 or 5. And then we have a number of clients in a cluster that will actually connect to that server and perform different operations. Just one thing to mention is, all of these clients, many of them are sort of communicating with each other, almost like kind of a mesh. So when I say clients on here, how many have I got? I've got 6 on here. We've actually got one of our customers who has 35,000 of those clients inside of a single data center, inside of a single cluster. So this kind of thing scales really, really well. And it's not simply a case of, everything talks to the centralized server. So somehow you have to architect for 30,000 servers all hitting like a single server at the same time. Because it's distributed, it kind of scales very well. Just to give you an idea of some of the people who are actually using Consul at the moment, we've got a list of some of the companies here who have actually spoke publicly about their use of Consul. I definitely recommend taking a look at some, there's YouTube videos, there's case studies and all those different types of things about how some of these organizations are using it. And of course, this is by no means an exhaustive list. Consul seems to be used pretty much everywhere. So the first question I want to answer really before I talk about what people don't know about Consul is, so what do people know Consul for? Like when I go and speak to people and I talk about all the products that we do at HashiCorp and we end up talking about Consul, they're like, oh yeah, Consul is that tool that is for service discovery, right? And that's absolutely true. That's probably one of the most popular use cases that people are actually using it for. And very briefly, the way that this works is, we have like a centralized service registry. So as services are coming up and going down, they register with this kind of central catalog, if you like, such that, if I'm a web server and I want to be able to talk to a database server, I need to know where it is. And I can use this centralized service registry to discover its IP address and be able to communicate directly to it. The other thing that it provides in terms of this is distributed health checking as well. So just because services are coming up doesn't necessarily mean that they're healthy. And so I don't want to ask for a database server and turn out that database server isn't actually running or isn't actually performing correctly. So we have all of these health checks that are going on. And because we have this kind of mesh structure, it's not simply a case of it's not going to scale because we've got one server trying to check 35,000 or something like this. All of the agents participate in what we call a gossip pool. So they're all sort of communicating with each other and providing health checks. And it's only really when a status changes that we actually update it. So how do people actually interface with Consul? Do you have to rewrite your applications? Well, fortunately not. We have a DNS interface. So that allows, if your application talks DNS, which almost certainly it does, you can actually use that to discover services. So again, if I'm a web server and I need to talk to a database, it's just a DNS query. We also have a HTTP interface as well. So if you want to interface directly with an API to have sort of direct console integration inside of your application, there's a full, rich, broad API that is available as well. So that's really kind of the main thing that people know Consul for when I talk to them. Oh, and one more thing as well. It's a KV store. It's a highly distributed, scalable KV store, a key value store as well. So if you want to make simple key value values available to all your different applications in a distributed way, it performs that very well as well. But wait, there's even more, and these are some of the things that we're going to talk about today. The first one I'm going to again just touch on fairly briefly is service segmentation, and the other one where we're really going to spend our time is service configuration. So if we add back in service discovery to these two things, so if we've got service discovery, service configuration, and service segmentation, these are all of the components that you'll actually need if you're building out a service mesh. Those are essentially the three main components that you're going to need. So just to touch on service segmentation briefly now, earlier this year, I was actually fortunate enough to actually be in the room when we were announced this publicly, is something called Consul Connect. So this is something that we added to provide sort of secure service-to-service based communication. Essentially allows all of your different components, particularly if you're breaking your components out into more micro services type architecture, to be able to communicate with each other securely using TLS. So even if your applications don't actually understand or talk TLS, you can actually use Consul Connect to enable this across all of your network. So immediately you'll see that all of the data being passed around your network, all that sensitive information is actually going to be encrypted as well. Perhaps different to how we would do this traditionally in a legacy way. We used to use IP addresses. That used to be our source of identity, basically. That doesn't really translate to how we view the world now, of course, particularly with cloud services, with ephemeral services, with containers coming up, going down. IP addresses are just changing all of the time. And we can't really get that agility that we're trying to move towards if we're using an old way of identifying our systems. So we're actually using the services themselves as an identity base. So again, a web server identifies themselves as a web server using TLS certificates. It can then identify itself to a database server. We use that for intention-based access. So we create really simple rules such as web can talk to DB, and that's one intention. Now imagine if that was a firewall and we had, I don't know, let's say we had 50 web servers and 5 database servers. I'd have to create like maybe 250 rules, or I would create a really coarse, broad rule that kind of had like an IP address range, which is a little bit too broad for most people. So I might have 250 rules in the firewall. That's only going to be one rule inside of Consul Connect. And the beauty of that is it's going to be scale independent. So if I started with 50 web servers and then 5 database servers, then I've got 5,000 web servers and 500 database servers, for example. That's still going to be only one intention. That's pretty much all I'm going to talk about today in terms of Consul Connect. But if you want to check out, there's a really good Hangout that my colleague Erin did. Erin's an absolute expert on all things Consul. I've put the link in here, and obviously when you get the recording to this video as well, it's going to be in the same place. So I recommend checking that out. But the thing we're going to spend most time talking about today is the service configuration side of it. There's lots of tools within here that even I didn't know. When I was looking at all the different things that that Consul was doing, even I was discovering new things that it was capable of doing. We've kind of touched on a little bit. We talked about the KV store, but the other ones we're going to talk about today are blocking queries, which is what a lot of the other technologies are actually going to be based on top of. Watches, locks, and ConsoleExec. So the first one is the KV store. What are you going to use the KV store for? Well, really, what do you want to use it for? There's many hundreds of different use cases. Some common ones are to hold dynamic configuration. So maybe I want to specify the port that my web server should be running on. I want to store that inside of Consul because I want to use that information and store it centrally. So, if I need to change it, I change it in one place centrally, and I can distribute all that information to all my systems, or, the maximum number of connections that that a server should open, or whatever it may be. It can also assist in service coordination as well. So again, an example of perhaps I wanted to mark a system or a service as being in maintenance mode. The fact is that because I have this KV store, and I can change one thing in a centralized place, it's distributed so it can be available to all of my fleet globally. I could mark a service as being in maintenance mode, such that it will no longer serve requests, and such that I would never use Consul to actually return the service that's currently in maintenance mode. A lot of people are using Consul to build leader election inside of their own applications as well. So imagine that you were to create a system such that you had a finite number of resources that you had access to, and you wanted it to be highly available, and you would bring up a number of systems, but only one of them could be a leader. Only one system could get a lock on a piece of hardware, for example, or a particular resource that is limited in number. People are actually using Consul to actually build that into their own products as well. Or something simple metadata. People might want to be storing that inside of the KV store as well. Or really anything else that a developer can think to build. Consul provides this as a tool for you to use inside of your applications. It solves a number of challenges of how can I centralize this, how can I distribute this, how can I make it stable, how can I make it performance, so that the developer doesn't have to think of that, and they can start building what functionality they want to around the features that we have inside of Consul. Now, in terms of the KV store, there is a user interface. I'm actually going to show you this a little bit later on the sort of hands-on demo side of things, but you can access the information in the KV store via the API, via the CLI, which is what I'm going to use a little bit as well. And there's also, as I say, a user interface where you can set some of these values as well. I want to move on and talk a little bit about blocking queries, because blocking queries is kind of what all of these other technologies are based on. So the idea of a blocking query is we use that to wait for a change using basically a long polling. So basically, I would make a request to one of the endpoints inside of Consul. And there is actually many endpoints inside of Consul that support blocking queries. But a real simple example is the KV store. It's quite an easy one to understand. So imagine I request a value from the KV store. It returns that information to me, and it returns it with an index as well. That index essentially is going to be a number, and it returns as X Consul index. What I can then use that index for is on subsequent requests, I can set it on a subsequent query to retrieve the key again. And what will happen is it will actually look as if the process is hung. Nothing actually will get returned. But what it's actually doing is long polling is enabled. So that process is essentially waiting for a response. And that response will be sent either if there is a change. So if I was to change that key value, it would send a response back to the HTTP client that was waiting open, or if there's a timeout was reached as well. So it may be that the value doesn't actually change, but I hit the timeout and I just send a response to say the value hasn't actually changed. How that might actually look on the command line. This is using curl. So basically, I'm actually checking the health of a service here. So this isn't checking a key value. This is checking the health of a service, which is called training. And the first time I do that, I get an index back of 522. I then submit another request, which basically I include that index. I've got question mark index equals 522 at the end, and nothing really happens until the health of that service changes. So if the health of that service, all of a sudden that service goes down, it's going to return a response to me to say that the health of that service has actually changed. Just to do this a little bit in a more pictorial form. So this is essentially what happens. HTTP client sends a request into Consul. Consul sends the response back in the metadata. Now that might be it at that point. I'm not really using a blocking query at this point. I've requested some information, and it's returned that response, that data, and it's also that index inside of the metadata. But then what I can then do with that information is resubmit it. So I can send another request to one of the endpoints. I can specify a wait period if I want to, or I can use the default one. And I also include the index. And then, as I say, seemingly nothing happens. The connection is is maintained, the connection stays open, but nothing actually gets returned until there is some kind of state change. And when there is a state change, we return a response with the new metadata that's going to have a new index number. And then if I want to, I can repeat this process as many times as I want to. So watchers is something that's actually built on top of blocking queries. So it's a way that allows you, you can specify like a view of the data. So I've talked about the KV store. I've talked about the health checking. I can health check a service. Maybe it's to get a list of nodes, for example. So I could set a watch to say, keep an eye on this list of nodes, this list of servers. And if I add a new server to my cluster, for example, update a load balancer or something of this nature. There's a simple event system as well inside of Consul. So maybe I can be watching for an event. So if a new event appears inside of the queue, I can trigger some kind of action based on that event. And there's many more as well. There's a list inside the documentation which of the various endpoints will support blocking queries and will support watchers. Now, essentially, when we detect a change with watchers, we can actually then trigger an external handler. So, okay, one of these things has changed. Now, what do we do? Well, we can either trigger an executable, so take that data and do something with it, or we can actually take the JSON object that gets returned and send that to another HTTP endpoint, which then can consume it and do, I don't know, whatever, do some monitoring, do some logging, trigger another action or something like this. This is a simple watch where basically we are checking for nodes. So basically in this example, we've got just got one node. If I was to add another node to my cluster, for example, then it would actually return this information, which I could then use to, in this case, maybe set up DNS, or as I say, add a system to HA proxy or something like this. Another feature we have is for locks. So I talked about that leader election mechanism. This is one of the areas that people can actually use Consul for. So if you wanted to build some kind of distributed locking, obviously maybe you could build this yourself, but you need to make this scale. You need to make this work across your entire fleet, and also you need it to be simple, and it also needs to work, right? So the way that locks actually work is we specify a lock, that we require a lock. We specify a prefix inside of the KV store. That's why the KV store is so important. That's why the fact that it's highly available, it's durable, it's distributed, it has global access. That's really important. You can't build these kind of technologies if we didn't have things like the KV store and the way that Consul works in that kind of mesh approach. So the lock is actually created inside of the KV store. Now, the default way that locks work is there is a single holder of that lock. So this is actually how we perform leader election in another one of our products, which is Vault, which is our secret management solution. We're actually using Consul locks such that we only have one active leader at any one time. Typically, in a Vault cluster, you have 3 Vault servers, but only one should be the active leader. And we're using that mechanism inside of Consul to make sure there's only a single one. Now, the great thing about that is, if the leader fails, I don't know, the server crashes or the process fails or for whatever reason, essentially you're going to have systems that are in a standby mode. They're kind of in a hot standby, just waiting for that event to occur, such that they can then take the lock, which will get released when the active one fails. They'll be able to take the lock, they'll become the active system, and therefore you won't have any kind of service outage as well. But it also supports semaphores as well. So when you need multiple slots, for example, inside of a lock, so for example, I don't know, maybe you've got 10 processes that are running that are reliant on some kind of hardware device, but you've only got 5 of those hardware devices. You can actually use a semaphore to say, well, 5 of those processes can have a lock on those hardware devices. And if one of those processes was to fail, one of the others in standby could then get a lock on that service as well. So it tends to be really useful for when you want kind of highly available deployments, the type of N+1 deployments you want to have, hot standbys available. People are using it quite a lot for this. Here's a simple example whereby we're using a lock. We're actually specifying -n equals 3. So we're saying we're creating a lock, and we've basically got 3 available slots inside of that lock. Now, each one of those processes runs some sort of Python script called foo. So I have a service called foo that is actually running, and basically the first 3 that actually can get one of those slots will actually run, and the 4th process isn't going to run, but it's waiting. It's waiting for one of those first 3 to actually fail such that it can then take over. Okay, ConsoleExec. So ConsoleExec is a mechanism for providing remote execution. You can actually do local execution. When I actually do the demonstration, I'm going to run everything just on my laptop. It keeps it nice and simple. It means you can follow along and actually recreate it. So you can actually do it for local execution as well. But it's a great mechanism for providing some kind of orchestration across a number of systems. It uses the key value store again. Funnily enough, I keep saying how important that key value store actually is. It actually, places a job inside of the key value store, which is then going to be picked up by your various different nodes or services or processes or applications that are actually running, such that it will execute that process across all of them. Has to be said, it doesn't actually guarantee execution. That's one of the downsides of it. I mean, it got pretty good execution across large fleets, but it doesn't provide that kind of guarantee mechanism. So that might be something that you want to build in. It's also disabled by default. Just want to mention that in case you try and do this and you're like, hey, those commands don't actually work. The reason is because by default, I guess for obvious reasons, people don't want to just be able to perform sort of privileged or remote executions across their entire fleet. So there is something you actually need to set inside of the config, disable remote exec as false. Watch out for the double negative there. You need to set that to false, which will actually allow you to use that feature. And also it can, you can filter on nodes or services as well. So this isn't just kind of okay, I've got 1,000 systems, it's going to run on all of 1,000. You can say, I want to run this on all of my systems that are running the web service, and I want to restart the web service across all of my systems for some reason. So a simple example of this is run ConsoleExec. You're targeting just a single service. In this case, it's Reddit, and you're just going to get the uptime of a system. What's nice actually though is you can combine a couple of the features that I've just mentioned, that I've just talked about. So you can actually use ConsoleExec. So I can run this across all of my systems to say I want to do a reboot, but I'm using the lock feature such that only 3 systems at any one time will reboot. So as a system wants to reboot, it has to first establish a lock, then the system can then reboot. The lock becomes available, so then another system can reboot. So it's kind of a nice way of doing some kind of concurrent reboot across all of your systems while it's limiting it to a number of things. So it's nice to be able to combine a couple of those different things together. So that's enough talking. That's enough slides. I'm going to get a little bit hands-on now. I'm going to walk through each thing. I've created some real simple examples. Basically, the process is going to be as simple as this. You download the console binary. So by all means, if you wish to follow along and you're a quick typer, you can follow along by downloading the console binary. We're going to run it in dev mode. Dev mode basically allows us to get up and running with console super quick. I can run this on my laptop. In fact, I can download it and I can run it in dev mode on my laptop. That might take a minute, 2 minutes, 5 minutes if I go and get a coffee. So it's a real quick way. I don't need to build out lots of infrastructure and set it all up if I just want to get hands on and try some of this stuff. All the scripts and the commands are going to be are available at this link. I've created a gist on GitHub, so I basically got all of the commands. They're really simple examples. It's a bit.ly /2z capital U 0 CD 3. So if you're watching this back on the video, I'm going to leave that link up there so you'll be able to follow along. So with that, let's get a little bit more hands-on. So the first thing that you're going to need to do is download the console binary. So where do we get that from? Well, it's available on our website. You go to console.io. It's the main page for Consul. There's lots of information on there about all of the various different features. Lots of information about the service discovery side, the service segmentation side, which I'm not really going to touch on too much. It's obviously also where our documentation is. It's all available. It's not hidden behind any kind of login. You can go and take a look at that. But the thing we're most interested in is the download. So we hit the download. This is open source as well. So if you wanted to, you could go into GitHub, you could download the source code and compile it yourself if you wanted to. If you're like me, who would never do that, we've actually compiled some binaries for some of the common operating systems here. So I'm going to be using the macOS version of this, but obviously if you're running this Linux on Windows, we've got binaries available for both of those systems as well. Hey, maybe you're running FreeBSD or Solaris. I'm sure there are people out there that are actually running those as their daily drivers. You can actually download it for those systems as well. In terms of the install process, it's kind of deceptively simple. You download a zip file, you unzip it, and there's one binary, and then you just run that binary. There's no sort of install procedure. It's pretty simple and straightforward to use. So with that being said, I've already downloaded this to my system. Did that a little bit ahead of time. So all I'm going to do is just sort of walk through a series of scripts. I'm going to take you through them one by one, explain a little bit about what they do, run them. Let's see the output. It's based on the kind of stuff I've just gone through there. So the first thing to mention is, remember I said that you needed to add a little bit of configuration? Well, this is the configuration that you actually need to run. Disable remote exec, set that to false. That's assuming you want to use the remote exec feature. Of course, if you don't need to, this is not required. You wouldn't actually need a configuration file if it wasn't for this feature. Then what I'm going to do is I'm going to start Consul, which is as simple as I say. Download the binary, unzip it. You'll get this executable called Consul. It's a fat Go binary. Then we just pass in a couple of flags. Agent, we're running it in dev mode, which kind of enables some features, disables some features. It's kind of a sandbox mode. You would obviously never do this in production, but it just means you can get up and running pretty quickly. And then I pass in the configuration file. So if I just run this, really as simple as that. And that's it. It's up and running. Like if you downloaded it, you probably got to this stage quite quickly. There is a web interface. I'll talk more about this web interface in more detail a little bit later. But this kind of will provide you kind of with an overview of all the services that you have running. Obviously, I'm just running this locally, dev mode, so it's not really like not particularly production-like environment. So I'm going to only have one service in this. But you can imagine you could have your web service, Apache, Nginx. MySQL might be running in here, MongoDB, front end, back end, whatever it is that you define, all of those things could be listed. The health of all of those different things is going to be in there as well. Also, we have the node side of things as well. So all of these services are running on something. In my case, they're running on my MacBook. They're running locally. I can see that my MacBook is up and running and it's actually working, thankfully. Hopefully you can see me. So we know that that's working okay. But the area that I'm going to just touch on now is this key value store. I keep talking about this key value store. It's seemingly so simple, but it's so powerful because it enables a lot of all of these other features. So in terms of creating one, I'm just going to create one in here. I'm just going to type in, I don't know, test app one, I don't know. And it's path-based, so you can make this hierarchical as well. So you can have multiple different levels. So I could have had test, app one, configuration, HTTP port, whatever it may be. I'm just going to set this to 1, 2, 3, 4, and hit save. And that's it. It's a key value store. It's pretty easy and it's pretty simple. Now, it'd be pretty boring if I only had this value. I need a couple of other values. I'm actually for this demonstration. So I'm just going to populate that KV store with just four simple keys, really simple and easy. These are the 4 here. I've got a couple for configuring a HTTP server perhaps, and a couple for some dynamic website creation. So again, real simple, populates those. And now if I was to hit refresh on this, I can see all of those values. In fact, let me get rid of the test one. We don't actually need the test one to just confuse things. So I can see things like, okay, I've configured a service called HTTP and I've specified what port my web server should be running on and what my log directory should be. So let's talk a little bit about a blocking query. So this script, basically what it's going to do is it's going to return one of those keys. So in fact, let's just get this running and we'll actually see. It returns the key for the port. Now I've got the port set to, let me just make that a little bit clearer. I've got it set to 80 at the moment. It's actually returned that as its base 64 encoded. So if I was to decode that, that would actually return the value of 80. You notice here it seems to have hung. It's basically saying waiting for changes. Now the thing that it's actually returned is not only the value, which was port 80, but there's some other metadata in there as well. The important one is this modify index. So the create index is basically, so for every key value will be given an index. They happen to be the same because it hasn't changed since it was created. So they're both 17. So that's what this first sort of curl command has done here. The second curl command is I just want to grab that index. So it's going to grab out the value of 17, and then it's going to pass it to this third command. And notice at the end here, I've actually passed in the actual index. So this is going to pass in index equals 17, but nothing seems to have happened. The reason nothing has happened is because it's waiting for a change. So if I was to change the value of this port from 80 to, let's say 8080, and then I hit save, watch what happens over here on the right hand side when I hit save. Boom, instantly it's returned that information back, and this value here is base 64 encoded version of 80. If I was to run this again, same sort of process would actually happen. It's going to wait, but notice now the modify index has changed. It's now 28, and obviously every time I change this data, that value is going to iterate as well. So I'm going to change it from 8080 to, I don't know, 9090. Maybe that's the port I want to use. Boom, instantly, as soon as I hit save, it returns the response with the new value of the port and also the new modify index. Now, you can build lots of really great technology on top of blocking queries. We're trying to help out. We're trying to put some of this functionality together for you to kind of maybe take some of the burden off you. This may be blocking queries, maybe all you need, and you can go ahead and build something on top of that. But also what we can do is we can use this watch feature. So I can actually use this watch to say, watch something. In this case, I'm watching a key. Maybe I'm watching the list of nodes. Maybe I'm watching the health of particular services. But in my case, I'm going to check the value of this log directory here. Now, let's run this one. Let's see what happens. Okay, so we can see here that it's watching for changes to the log directory. It returns what the current value is. So the current value is httpd access_log. I've just got to, basically what happens is it runs this watch, and as values change, it will then execute this this function here. This is just a simple function. It doesn't really do anything particularly useful other than display some information on the terminal for us. But you can imagine that I might actually perform some sort of command, reload a service, or write to a file, or notify some other system, or just provide some kind of input to some kind of binary that's actually running. In my case, it just pulls out the value, just decodes it from base 64 so we can all read it and understand it. But again, let's watch what happens if I change this. So imagine that this is my log directory for HTTPD, and I move away from rel and I move on to, I don't know, some Debian-based system. So maybe the path has actually changed. Again, watch what happens on the right-hand side when I hit save. I hit save, and there we go. Instantly, the watch picks up the new value and passes it to this process. Now, one of the things you might have noticed that's slightly different is this process didn't actually exit. It still continues to watch. So it creates a new blocking query after the first one completes. So imagine now I want to change this log directory again, and I want to change this from Apache to, let's go with Nginx. We're getting rid of Apache altogether. I'm going Nginx. Hit save, boom, it changes over here again. Now, you might use this to then go ahead and configure, I don't know, maybe you use this to configure Apache, or maybe using this to configure Nginx to say which log directory it might use. Maybe you're using this information and passing it to another system to say, hey, this is the directory I want you to monitor for my logs. But this is the thing, it could be anything. What do you want to do? You can kind of build really any sort of tooling around this that you want. We can also do this for events as well. So we can use this Consul event command to basically send an event into an event queue. We give it a name because we need to say later on which of the event names we want to watch. And then we provide a simple payload. This literally says sample payload, but it could be go into maintenance mode or perform some kind of orchestration or I don't know, reboot or whatever it is. You can build some kind of tooling around that. I put a sleep 3 in here simply because otherwise this just happens really quickly and it's kind of a little bit hard to follow along what's actually happening. So let's run this one. So it creates the event and then we wait for 3 seconds and it's already happened. We create a watch that actually looked for this event. And obviously, if I was to run the console event command again, once I'm running the watch, I would have a new event in here, maybe with a different payload. Again, that payload here is this payload here. That again is the base 64 encoded value for sample payload. But again, that could be anything. It could be anything that you need, and you can do that. Use that to perform some kind of orchestration as well. Okay, let's talk a little bit about locks. So the first kind of let me just clear this a little bit. The first thing that I'm going to show you is just a single lock. So I'm not doing anything particularly exciting with this lock. The process that you'd actually run when you do this for real would be something that's a little bit more exciting than sleep 10. I don't know, maybe start a web service or, I don't know, pass a command to something to say that it has the lock. But essentially what I'm going to do here is I'm going to start 5 processes, 5 sleep 10 processes, all at the same time. All of them are going to run. But I'm going to set a lock in this particular location. So service HTTP lock. That's the location I want to put that in my key value store. And then I'm going to run some kind of command. Now, what's going to happen is as we iterate through this, we're going to see which process has the lock. Remember, there's only one lock. There's 5 processes, but only one of them can have the lock at any one time. And as this sleep process completes, as every 10 seconds goes through, that process will basically finish. The lock will become available, and then something else will take the lock. So let's run that and see what happens. Okay, so process 2 has the lock. Now, kind of interesting, it wasn't process 1, as you might have expected, but there's an element of randomness that's added into this, so you don't get some kind of like cascading herd situation going. So there, basically, process 2, sleep 10, it ran for 10 seconds, it stopped, the lock was released, and immediately 5 picked it up. So now 5 has the lock. 5 might be the active system, and then this process continues. 5 has released the lock, and 1 has picked it up. So now 1 is the active server. Now, typically what really should be happening is I should be restarting those processes. I should have some system that basically is checking that my process has failed and restarted them, because essentially I'm exhausting all 5 of my systems. What would really happen is one of those systems would go down. You'd have some kind of monitoring to say that you've got some kind of outage, and then you would go ahead and restart that system, and then you'd always have kind of 5 running, and kind of one of them would always be the leader and 4 would always be waiting. In my case, they were kind of exhaustive. I went through all 5 and they all kind of died off. But it just kind of shows you that each of these processes can have the lock. They could be the leader. They could have this is just a real simple operation, but it might be you've got some kind of hardware system such that only one of them can have that lock at any one particular time. And I'm going to do the same thing, but instead of doing just having 1 available slot inside of my lock, I'm going to have 2. It's easy to do. That's literally all I need to add. -n equals 2. I'm actually using the same location for my lock. The rest of the process is the same, but essentially what it means is when I run this, and let's just kick it off, 2 processes now have the lock because there are 2 slots available. Guess what happens when those 2 processes die off? 2 more processes will actually pick up that lock. So I've always got 2 running concurrently at any single time. So let 1 finish. Now, the thing is that I've only got 5 processes. So at some point, there'll only be 1 process that's actually running. Even though there are 2 slots available inside of that lock, I've actually only got 1 service competing for it. So you can see that 3 and 5 were running, 4 and 1 was running. And then by the time I got to 2, that was the only one left standing. So there's actually only 1 system that had the lock. But you can build this for anything. If you need to use any kind of semaphores, you can actually use this lock mechanism inside of Consul for this. The exec. So I've got remote exec running, but I'm going to run everything just locally on my laptop because it's quite easy to demonstrate and show. So the first thing it's going to do is just going to run an uptime. The second thing it's going to do is just a simple ping of Google. Imagine I was running this across all of my different systems. I could soon pretty quickly kind of process this information and go, wow, that machine's really slow at pinging something. Maybe there's some kind of issue with a network there. And then the last thing I'm going to do is I'm going to be a little bit crazy, is I'm going to use ConsoleExec to run remotely on as many machines as I wanted to, just 1 in this case, but imagine I was doing this across a fleet of systems, to actually take the uptime from my system, put it into the key value store in the path that actually matches the host name. So let's do that, and let's see what that looks like inside of the key value store when we run that. So the first thing we do is we check the uptime. So yeah, my MacBook's been up for 1 day and 18 hours. The next thing we're going to do is ping Google 5 times. I only want to do it 5 times, as we'd be here forever. Oh dear, look at that, terrible latency. And then the final thing it's going to do is it's actually going to run the uptime on my system again, but it's actually going to put that into the KV store, and that's done. That's already run. Now I'm only running this on 1 system. I could distribute this. I could pin it down to say run it on just my database servers, or just my servers with a particular tag, or what kind of filter I want to put on. Let's have a look at what that last one did. So that last one it created see, it's in machines. So it should be in machines. It took the host name of my machine, created a new key called uptime, and boom, there we go. It's actually put the uptime of my system inside of that key value store. That's kind of a bit of an arbitrary example, but you can kind of see, you can kind of build on all these different features and do anything. You could do a remote exec across your feet to collate some information that is only available when you're on the local machine, and then return that to a central KV store. Last couple of things real quick. So again, we're trying to make this as easy for you to use and build and consume as possible. One of the things that we have is a helper function called Consul template that will take a template file such as this. So this is just a real simple example. It's a web page, the simplest web page you'll ever see, and it's basically taking those keys from Consul and rendering them into a file, and then it will just say I've generated the new web page. So let's run that real quick. So that's it. It's generated that. So I should now have a web page here. There we go. So I took that dynamic configuration from Consul. If I go back here real quick, go into the website, go into the content. Consul template is great, which is what we actually saw on that web page. It's just worth mentioning that Consul template's a separate binary. So do a Google search for it. You'll actually find a link to it on GitHub with all the documentation. I actually just ran this as a one-time thing, but you can actually run this as a daemon. So imagine that you wanted to take, I don't know, configure your web server, and you need to take the value centrally, put it into the KV store centrally, run Consul template as a daemon, and every time you changed it, it would output an Nginx config or an Apache config, and then we pass some kind of command to it such that it will like reload the service, for example. Now in this case, it doesn't seem to have done anything, and the reason it's not done anything is because That file already exists. It's already got the right information into it. But watch what happens if I change one of these things here. So I'm going to put a couple of line breaks in here, and I'm going to say config is easy with console. Hit save. It triggers, it uses the blocking query, it triggers an update, it renders the file, puts it out onto disk, and I now have a new web page that says config is easy with console. And you could use this for anything. I've done it for a web page, it's quite graphic. You could use it to configure any kind of service. You could put all of your information centrally. You want to change it across your fleet, you change it in the KV store, and boom, it gets rendered out across all of your different systems. And with that, I think it's time for some Q&A.
Hi, everyone. So we're now going to switch over to the Q&A session with Russ. If you were originally watching this live, you saw that we unfortunately had some technical difficulties during the Hangout. However, we still wanted to go ahead and get all those questions answered for you. So backgrounds maybe changed a little bit, outfits changed, but we're still going to get through those questions. So Russ, the first question was, what are some of the advantages of using Consul over other service mesh tools like Istio?
Okay, yeah, really great question. So some of the differences, I guess, between Consul and Istio. So Istio is very focused around the Kubernetes platform, whereas sort of Consul is very sort of agnostic of the different types of platforms that it can work on. It can work on Kubernetes, absolutely, but also all the different cloud providers, virtual machines, on-premise, all of those different things as well. Also, Istio tends to be very much based around layer 7. Whereas Consul can actually work at layer 4 and at layer 7, just the way that it's actually architected. So some of your applications that have no idea how to talk layer 7, you can use those with Consul and Consul Connect, because it will actually talk layer 4 as well. And I guess maybe the other feature, one of the things that a lot of customers have sort of fed back to me about Istio, is they've got some concerns over its kind of its stability and how perhaps ready it is for production environments. Consul's been around for like 4 years. It's one of our most stable products, one of our most well-developed products as well. So just at a high level, those are sort of some of the main differences.
Great. Okay, thank you for clarifying that. And then next question, how many DCs can Consul Service Discovery work across?
How many DCs do you have? I guess would be the question. So Consul will actually work across multiple DCs. We have something called the WAN gossip pool, where basically you can connect multiple data centers together and have discovery between them. A lot of people are actually using that to have service discovery across not only different data centers, but different platforms as well. So their on-premise environment talking to their cloud environment, such as in AWS or Azure or GCP or one of the other different platforms as well. And there's actually some real nice integrations between different platforms, such as the service discovery inside of Kubernetes can synchronize with the Consul catalog as well. In the same way, there was a recent announcement at AWS reInvent recently, where they introduced one of their sort of new technologies, their cloud map technology, and we had day zero support for basically synchronization between the AWS platform and people's existing Consul platforms as well. So maybe you want service discovery between AWS and Consul. You can do that as well, and you can have more than 2 DCs. I talk about 2, but you can actually have multiple DCs as well.
Okay, awesome, thank you. And then next, can Consul help with mass configuration for infrastructure on-premise?
Absolutely. I mean, it's not tied to any of the cloud platforms. So obviously, it's one of the most popular service discovery tools on the cloud platforms. And AWS definitely announced recently that it is the most sort of popular tool there. But yeah, absolutely, we've got lots of customers who are using it for their on-premise environments as well. So it can help in the on-premise in the same way that it can help in the cloud as well.
Awesome. Okay. And okay, next one. Can you run the same? This is a bit kind of an add-on from the on-prem. Can you run the same Consul across multiple cloud providers?
Yes, you can. So in the same way that you sort of kind of an extension of the multi-DC question that we sort of answered a moment ago. So you can have as many different cloud providers, different regions within cloud providers as well. The one thing I would say is Madam, maybe there's sort of a question behind the question in the sense that can you have the same Consul cluster spread across multiple environments? Consul actually will sort of needs a single cluster has to be in a low latency environment. So typically what you would do is you have multiple clusters and then have connections between multiple clusters across different cloud providers.
Okay, awesome. And next one, can you use Consul Connect in a multi-data center environment?
Yes, you can do actually. So one of the things that we announced in Console Enterprise 1.4, which we announced at HashiCorp around about the end of October, was support for Console Connect in a multi-data center environment. That is actually limited to the enterprise version, but yeah, absolutely, it's possible to do. So you can have that kind of end-to-end TLS connection between different services across multiple data centers and Console Connect in Enterprise 1.4.
Perfect, thank you. Okay, and the next question, apart from the storage backend for Vault, what else is Consul useful for with Vault?
Oh, great question. Yeah, so there's a couple of things. So Vault itself, that's our secret management solution, uses a storage backend, and the most popular one and one of the most stable and reliable is Consul. It actually uses the Consul KV store to store sort of all those values. It's obviously all encrypted. So you saw me when I was actually doing the demo. I was putting data in there and text in there, and we could read it back. Now, obviously, with all of your secrets, you don't want to put them in there in plain text, such that someone could take a look at them and actually read them back. So all of that information goes in there encrypted in the storage backend. Now, there's kind of two other really useful things that Consul is used for with Vault. Well, actually, yeah, a few things. Actually, the storage backend actually implements. Remember, I talked about the locks. Such that you can kind of have a leader election, such that only one of your systems will have a lock. That's one of the things we use for Vault. Another thing we use it for is health checking as well. So as Vault services start up, they register themselves with Consul, such that if they've got any issues with their health, the server crashes or the process hangs or anything like this, it can trigger another leader election, so one of the standby servers can actually come up as well. And one of the most popular use cases is for access to Vault. So if you wanted to provide access to Vault and you've got multiple systems, multiple servers inside of the cluster, what you would use Consul for is the service discovery element. So if you wanted to talk to the active Vault node, it's just a simple query to Consul. It retrieves that information from the catalog, and then you can then talk directly to the active node inside of Vault as well. So apart from the storage, it's kind of the health checking side and the service discovery side is what we use it for.
Great. Okay, thank you for going into that detail. Okay, so now just one more question, Russ. Final question is, someone's wondering, based on your example of watching a list, if something changed on that list and they wanted it to trigger a backup of the Consul servers, can watches trigger automated backups with automated backups in Consul Enterprise?
Yeah, I guess there's kind of a few bits to that question there. There's kind of like multiple questions kind of squished together. Let me take a stab at that. So you could actually, basically, a watch watches for some kind of state change inside of a list. It could be checking the the health of nodes, the health of a service. You can do that. Check the event queue as well. I actually saw that within that, and then you could trigger a process such as doing a backup. So one of the things that you can do in Consul, there's a functionality called a snapshot, which is pretty much as it sounds like. You can take a snapshot of the data inside of Vault and inside of Consul and put it onto like a file on disk or something like that. So you've got that kind of backup strategy. The question there was talking about automated backups in Consul Enterprise. By the very nature of automated backups, you wouldn't need to trigger them in any way. So in Consul Enterprise, you can actually run a daemon. So that snapshot will actually run on a daemon. It'll actually run on a schedule, and it will basically take those backups and then maybe send them to like an S3 bucket. And you can schedule that to be as often as you want, like maybe once a day or maybe once an hour, whatever it is. So they're kind of separate features. I wouldn't necessarily recommend using watches because you're not quite sure whether that watch is actually going to be triggered or not. So you're probably going to want your backup to run on a regular basis. And so that's why we have that kind of automated daemon that runs in Consul Enterprise.
Okay, great. Thank you for getting through all the sub questions within that question. So that wraps things up. Thank you for all your expertise on all of that, Russ. And for everyone else, as I mentioned, this was recorded. It's going to be sent out to all of you along with these questions. So I hope you all enjoy today's Hangout and have a better understanding of Consul's full capabilities. Thanks for hanging out with us, and a big thank you to Russ for his time today. That wraps things up for us. Have a great rest of your day. Goodbye, everyone.